this example, we have a beaker that has 1,000 milliliters of water, which is equivalent to 1 liter of water or 1 kilogram of water, and it's sitting on a hot plate. And we're going to add a certain amount of energy to this water and see what happens to the temperature. So since this is water, we know that the specific heat of water is 1 kilocalorie per kilogram degree Celsius, or 1 calorie per gram degree Celsius. We're going to add 10 kilocalories of heat from the hot plate. The mass is 1 kilogram with 1,000 milliliters of water, and we're interested in knowing what happens to the temperature. So we're interested in, does the temperature change when we add this amount of energy? And so when we put in 10 kilocalories for the heat, and then we divide by the mass times the specific heat, we see that the change in temperature of this water would be 10 degrees Celsius under these conditions. Now, what we'd like to know is what happens if we have more or less water. So we consider the same example where we're adding the same amount of energy here. So we have it on the hot plate for the same amount of time, adding 10 kilocalories of energy. But in this particular case, we have 2 liters of water, or 2,000 milliliters, which is equivalent to 2 kilograms. So again, we look at what happens to the change in temperature. And when we plug in here for the mass of 2 kilograms, we realize that the temperature changes by only 5 degrees Celsius in this case. So the change in temperature is inversely proportional to the mass. As we double the mass, the change in temperature changes by a factor of 1/2, keeping the substance the same and the amount of energy added the same. We could continue with this, and we could consider what happens if we fill this beaker all the way up so that the mass is 3 kilograms. And again, we'd like to know what happens to the temperature change. So again, we're adding the same amount of energy, but now, compared to the first example, the mass is 3 times as large as what we started with. And so now the temperature change is 1/3 of what it started. So remember, in the first case, the change in temperature was 10 degrees Celsius when we only had 1 kilogram of water, and now the change in temperature is 3.3. So again, there's this inverse relationship. As we increase the mass, the change in temperature becomes less when the same amount of energy is added. If we consider what happens when we change the mass by reducing the amount of mass, we can go through that same process. So in this case, instead of starting off with 1 kilogram, like in the beginning, we're starting off with 1/2 of a kilogram. And when we plug in 1/2 of a kilogram, we see that the change in temperature is 20 degrees Celsius. So by halving the mass, the temperature changes by a factor of doubling what it was to begin with, which was 10 degrees. And so less mass, if we add the same amount of energy to less mass, the temperature change is going to be greater.